L1 I think had about 227 volts, and then the L2 I think we had about 223 or so volts. But you can see, you can rewind and see for yourself. Hi guys, welcome to Asher and Gad channel, making Africa home again, one family at a time. So here for another site update. We're in the electrical room. I'm having a lot of questions about the electrical system, so I'm going to use this opportunity to explain a little bit more about how I've wired things, and but there'll also be an ebook with a bit more detail. So if we look at the electrical room again, I think somebody made a comment about that they used a similar distribution board in their home, which was a 12-way 3-phase, and basically it wasn't big enough. The electrician didn't count the number of circuits properly, and they ended up having to rip it, install it, pay for it, rip it all out, and put a bigger one in, which is absolute madness. Absolute madness. You always need to make sure, whoever is designing your electrical systems, and especially the electrician, that you count the number of circuits that you have to make sure that the size of distribution board that you buy can accommodate all your circuits. Now, I'll do a separate video on how to wire your house, but there are certain ways that they wire in Ghana. For example, they use a lot of radio circuits for their sockets. And what a radio circuit means is that I'll just demonstrate it in here. Here we've got a number of MCBs. These are called MCBs, and these are miniature circuit breakers, right? They're type Cs, right? But what a radio circuit just means, for example, if you were supplying a socket, you'd go from one of these C32 amp breakers and you go straight to a number of sockets, and your circuit will end at the last socket. But what I've done a mixture of ring and radio circuits. When you have some ring circuits, it saves you money. It's more economical, because what it means is that you can wire a number of sockets in a ring. It goes to the socket from the MCB and comes back again. If you have so many radios, you use so many MCBs, and you need a much bigger distribution board, and you spend much more money on the breakers as well. In Ghana also, the air conditioning units, they tend to put one air conditioning unit to one breaker, right? Which again is I understand why they do it, but it costs more money. Which means if you have 10 AC units in your house, you need 10 of these MCBs. What I've done is I have, let's say, 2 AC units on a circuit, and that circuit may be probably a 40 amp MCB and a 6mm cable, okay, which can do 2 AC units. But that depends on the size of the AC units. If you go for, depending on whether you go for 2 horsepower or 2.5 horsepower, or even 1.5 horsepower. So you have to work it out for yourself. What I'm saying is, you can have 2 AC units on one circuit, okay? As long as the cable is the right size, that is absolutely fine, and that's an economic design that will work fine and save you multitude of MCBs and the cost of the distribution board. Some people will say, well, what happens if you get a fault on one of the AC units on that circuit? It would affect the other one. Not necessarily. If you get a fault on the AC units, you can just turn off that AC unit, take it away, fix it, and bring it back again. So not necessarily. I guess there are pros and cons to it, but that's what I've decided to do, and I'll give more detail in the ebook for those who are interested. So that's the Eaton distribution board. It's pretty good. And so there you go. This is a 12-way 3-phase board, which means you get 36 single-phase ways. All right. So now let's come to the main changeover system. So this box here, in Ghana they call it a TPM, but it's basically just the incoming isolator, okay? That's where the cables from the meter outside, from ECG in the pole through the meter, come through here, and then from here, we have 4 changeover systems. And all that is we have 3 phases coming into this house, okay? Each phase that comes in is 100 amp rated, okay? And each phase can support my entire house, okay? Entire house. But this entire house, as I said in the previous video, and if you haven't watched the video about how much power do you need for your house, click right up here and you can watch that video if you like to recap yourself. Right, so this house needs about 48 amps, okay? We have 100 amps coming in on each phase, and I only need 1 out of any of the phases to power the entire house. So now I'm going to demonstrate it to you. So at the moment, we've got this automatic voltage regulator, and if Chris points at the screen, you can see that there's power on. I've got about 227 volts on the display. Now in Ghana, the voltage is same as the UK really. Between 220 and 230 volts is the nominal correct AC single phase voltage. So at the moment, the changeovers, the whole house is on L1. This changeover here is on L1, okay? That changeover basically feeds this changeover, okay? And then this changeover feeds that changeover, that changeover feeds that changeover, and then that feeds the distribution board. Currently, the house is on L1. We haven't got any lights yet. It's all bare wires. So the only way I can demonstrate it to you is by simulating. I'm going to simulate a loss of power. And if you just look, when I turn the power off, this number will go to 0, or the whole screen will go blank. Because as I've explained in other videos, there are houses that have only single phase in Ghana. And when you have only single phase and there's a problem with that phase, there's too much load on the phase, and therefore you have voltage fluctuation issues, or even if you lose the phase completely, you lose your entire house, okay? There are other homes in Ghana where they've also got 3 phases coming in, but what they have done is, in their entire house, they have 3 phases, and each phase does a portion of the house. Again, in that scenario, if you lose one phase, you lose a portion of the house. And I didn't want that. I wanted to come up with a design whereby I can lose one phase, I can lose 2 phases even, and still be able to support my entire house. Because each phase is 100 amp rated, and we only need 48 amps single phase for the whole house. So, back to the demonstration. So right now, the house is on L1, okay? That's it right there, on L1. So what I'm going to do at this moment in time, I am going to demonstrate the loss of power. So by doing that, I'm going to switch this off. So right now, this is in an off position. You can see there is no power, right? So that is like losing phase 1. I've lost phase 1, there's no power to the house. If my house is single phase, then that's it, Dumsor lights out. If that happens in this house, I'll just come up to the board here and say, okay, no problem. I've lost L1. Let me switch to L2. So all I do is switch to L2. There you go. Bingo. The power comes back. 227 volts. Power is back. I'm on L2. Let's say in the worst case scenario, let's say I've lost phase 1 and phase 2, L1 and L2. I will still have L3, which again is 100 amp rated to power the entire house, because the entire house only needs about 48 amps. So let me simulate again loss of L2. So here I go to the middle, which is the neutral part. Okay, so there's no L1 and there's no L2, there's neutral part. You can see that everything is off, voltage is off. So now what I'm going to do is, if Chris shows you guys, I'm going to move my changeover switch. I'm going to move it to the phase 3 position. And when I move it to the phase 3 position, all of the power will come back on again. So here we are. The off position, phase 3. There we go, bingo. Power coming back again. So 233 volts, right? And guys, if you're paying attention, you can see that the voltage is different on each phase. Okay, because here on L3, see I've got about 234 volts. On the L1 and the L2, L1 I think had about 227 volts, and then the L2 I think we had about 223 or so volts. But you can see, you can rewind and see for yourself. What that means, you can see, is they're not all the same. What that means is that L3 at the moment in the area is lightly loaded. There's not many people on L3, so I'm getting a much better voltage on the L3 as compared to the L1 and the L2. So the customers in the area, more of their loads are on L1 and L2, which is why I'm getting a bit of a lower voltage. Still within the 220 to 230 volt range, so still absolutely fine, okay? Now, again, so that's the L1, L2, L3 resilience of this changeover system. In the future, okay, let's say, or anytime, let's say I lose all 3 phases. If I lose all 3 phases as a total blackout, significant maintenance that's being done by ECG, no problems. All I do is I put this in the neutral position. Okay, I've lost completely. If we have a generator outside, but we haven't connected it yet, but if the generator was connected, all I'd have to do is move this switch to the generator position. okay, and the power will come back again. Okay, simple as that. If I did not want to use my generator and we have installed our future solar system, then again, all I need to do is make sure this is in position. All I need to do is, you see this PV? PV means photovoltaic system or solar panels. So if I lost all 3 phases and I don't want to use my generator because that's going to cost me money in fuel, I want to use, let's call it free energy from the sun, okay? Then all I do is I move this from here to there, to the solar panel position, the PV system, which we have the pipes in for already. Once we put the solar system in, we'll connect it all up, and then we'll get solar power from here to here, and then back to the distribution board. Okay. So I have total resiliency. I have resilience in the 3 phases coming from ECG. So I can lose 1 or 2, and still have power to my whole house. I can lose all 3 phases and come on generator. If I don't want to use the generator because that, obviously fuel is expensive and obviously to the environment it's not very good. So I want to use solar. Then all I do is I come and change it over to PV, photovoltaic solar, and I still have power to my house. We haven't bought the solar yet, but again, as I talked about in the other video, how much power do I need to run my house? Again, click on the link up here if you haven't watched it. We're not going to have 10, 11 kilowatts worth of solar power because we don't need to power our entire house. If you have lights out, it's a very airy environment. We only need really lights, fridge and freezers. So probably a 2 kilowatt system is probably fine, maybe even 1.5. So if I go on the solar system, before I switch to the solar system, I will open up this distribution board, turn off the breakers that I don't need, turn off the air conditioning, turn off any other heavy equipment that I do not need or that the solar system cannot support before I turn to solar, so that the solar only supports what we need at the bare minimum, which in our case is we decided lighting, fridge and freezers. Now obviously, before your electrician leaves your job and you do your snagging, make absolutely sure you open up your distribution board and make sure everything is labeled. Okay, what is sockets, what is lights, what's your cooker, fridge, freezer. You need to know exactly what these breakers support. At the moment, we put this as a polytank pump, one of the pumps, because we're just interested in that for now. But he hasn't finished it. We haven't put any switches on or anything like that. But all of that will be labeled, and that is a must before your electrician says he's finished. You have to have a circuit chart all labeled. Okay, so that's really the practical demonstration of the changeover system. What I've done is I've done an ebook for you guys. But before I even talk about that, when I first drew this up for the electrician, he said he understood, no problems. And this is not a typical setup. He said he understood it. But I actually knew he didn't understand it. So I quizzed the money. Then he came back to me, he doesn't really understand it. Quizzed the money, taught him about it, then he got it. Now, then I left him to it. He said he's installed it. I said, have you finished? Yeah, I finished. Then I came back to inspect it, and it was completely wrong. He hadn't done it properly at all. Now he's a very good electrician, but he's not an electrician who's come up through the education system. He's come up by learning as an apprentice, learning from a master, if you like, which is fine. He knows what he's doing, it's very good. But he was struggling with the diagrams and everything that I drew for him. So he did it where it was wrong, so I had to come on site, again, project manage, and tell him, connect this cable to that cable, connect that cable to that cable, and then everything was working fine. And I'm very, very happy about the end result. The point of which I'm saying is, this is a good resilient system, okay? But it's not something that some guys, you have to get the right electrician, because an electrician who can read drawings is nice, but if you don't get him, make sure you've got a good project manager so you can go through it and understand exactly how to wire it. In Ghana, I'm yet to come across somebody who says, oh, they can't do it, apart from a few. They like to say that they can do it, even if they haven't done it before. They want to use your house as an experiment. And electricity is not the kind of thing you want to do an experiment with. So I purposely was here to make sure every single wire is connected the way it should be connected. All right. So right now I'm going to return the house to L1, very, very simply. So to return the power to L1, I need to shift that changeover. That changer is the output of that is fine. Move that to L1, and there you go. Power is back, 229 volts. Okay, 229 volts back. So we got L1 here. The output of that, absolutely, just checking in my mind here, into there, of course, and which is on that secondary supply. Output of there into there. Happy days, and then we're out. We're good. All right. So guys, somebody asked me about this automatic voltage regulator. Yes, you can get them in Ghana. There are a number of electrical wholesale places you can go in Accra Central, in Makala, wherever, if you want it, that is. Now, we've experienced a lot of voltage fluctuation, even though we're living in a very nice estate. There's lightning strikes and the air conditioning is going off and on. The lights are blipping in and out. So voltage fluctuation is an issue. There was somebody who made comment about, what they say, in their area it's so bad that they have to change their fridges and freezers every now and again, which is a horrendous cost. Imagine having to change your fridge or your freezer, every so often. That's madness. So to invest in one of these is pretty good. I would say it's the right way to go. It really is the right way to go for you guys. All right, and before we go, make sure again that your incoming cables from ECJ are a minimum of 16 millimeters squared. In Ghana, they call it 16 mm. 16 millimeters squared would be the minimum for 100 amp three-phase supply for a 4-bedroom house. Okay, and again, if you haven't watched this video, I think what did I call it? I think I called it. Actually, it's the same video. How much power do you need to run your house? Go watch it, because initially the cables that were installed from ECG to this house were wrong, and I picked it up. So you can click up here and watch it if you haven't done so already. Okay guys, I forgot something the last time we recorded in the electrical room, so I'm just putting this in here just to add to what I said last time. Now this is really based on a comment that somebody made about the electrical changeover systems. He asked, why is it not automatic? Now the answer to that is, it can be automatic. There's no problem with it being automatic. That is a personal choice, and I made that personal choice based on the risk profile of the area that we are living in, and also based on cost, because cost is a design parameter in itself. If we look at these changeovers, okay, we've got 4 changeovers here, all right, and each of these 4 changeovers is about 600 Ghana cedis, okay, 600 Ghana cedis, which is about what, in pounds, it should probably be about, I don't know, maybe 75 pounds, something like that, each one of these. And so that's 4 of them, okay, so that's 2,400 Ghana cedis for all 4, or about, let's say, 300 pounds for all of these, or $450 or so, real price on your screen. If they are automatic, you can get automatic, quality automatic changeover switches or automatic transfer switches, ATSs, from MEM here in Ghana. They go for about between 4 and 4,500 Ghana cedis each. That means one of these, if this is automatic, okay, that will be, one of them will be, what, almost about 600 pounds almost, actual price on your screen. So I've got 4 of them, so I'm either paying 16,000 for all 4 of them, about 2,400 pounds, or I'm paying 2,400 Ghana cedis, which is only about 300 pounds, okay? So that was what we decided to go for, because I didn't really need it to be automatic. Electricity in the area is reasonably stable. It does go off every now and again, but reasonably stable. And again, that's a personal choice, which I'm more than happy with. So yeah, that's what I wanted to say on that, really. But whilst we're here, it's interesting that the voltage today is quite low. Okay, we are on L1 as it stands at the moment, and the voltage is 218, which is quite low. Okay, but I haven't actually put the stabilizer on. For anyone who's wondering, at the moment the power is just going through the stabilizer. The stabilizer isn't on. I haven't turned it on today. Just having the raw power going into the house, because there's no one living here. There's no one living here yet. We haven't got our equipment here. It's just workers on site. So I don't really want to get my stabilizer working. I want to enjoy the full life of the stabilizer. So when we're moving and all our critical equipment is in the house, fridges, freezers and stuff we really care about, then I'll put the stabilizer on. I have tested tested the stabilizer, but it's just interesting to see that we've come here today and the voltage is below the 220. It's about 217, 218, which is not too bad as well, because I need to check the Ghana regs. But if I use UK as an example, UK nominal voltage is 230 volts single phase, and it's plus 10% minus 6%. So anything in that range is okay. So the plus 10% takes you to about 246 volts, and as a maximum, a high maximum, and a low minus 6% on 230 volts. I'll put the number on your screen because I can't work it out in my head. But anything within that range is okay. So 217 is still okay for the operation of your household equipment. It's still fine. But it's just interesting that it's a bit lower. That means people in the area, a lot of their loads are on L1. Probably a number of single phase houses in the area who are on L1, causing the voltage to dip on that phase. So guys, just before I go, in the ebook, what you're going to get is, you're going to get the actual electrical schematic, the engineering drawing of this changeover arrangement. Not only are you going to go and get the engineering drawing, you're also going to get the actual wiring details to show you what cables go where and the size of cables that they should be. You're also going to get details of these specific changeovers, okay? The internal wiring of it and how much they cost, where to get them from. The same thing with the automatic voltage regulator. The same thing with the heating distribution board as well. So you're going to get a few more details for those who are interested, that is, because it's an engineering setup, and that could, if you're interested in that, then that could help you as well. Another alternative system, again, this all depends on how much you want to spend. Obviously, this is a resilient in the phases to the house. It has a solar connection, it has a generator connection. But if you only want to be resilient in the phases, you know, in the ebook, I've done another diagram where you can have 3 phases coming into your house. If you lose one phase, you simply change the device and your house is powered off another phase. If you can lose 2 phases and the house can be powered off the 3rd phase, no problem. So if you just want that resilience in the 3 phases coming into your home, and if you lose 2, you want your whole house to be powered, that is fine as well. You don't necessarily have to have the generator and the solar backup as well. So I've included that second option also in the ebook for those who are interested. Okay, so I think that's enough information for one video. From you it's
Kamisia.
Guys, Ibeshia. See you next time.